Today we are going to discuss basic STL programming. But before we will go to the advanced, let's start with a basic. So first, you need to download this useful PDF file. This will guide you on how to learn STL. So everything will be here. I will also give you the link below for you to download it. And we have also the STL sheet. So all of the list will be here. For today, we will only going to discuss the an, on, and equals. And we will also cover nesting. So A stands for and, an stands for and not, o stands for or, on stands for or not, and equals is the output. So now, we'll start with a basic exercise. So if you are going to convert this into STL, how you will do this? So I created here one block for STL only. So first, we will convert this into STL. So it will be simply, so I will do like this. So first network will be this. A, which is AND, followed by the address. Then since the output will be equals M 0.1. Okay, so this is the STL conversion for this ladder diagram. How about the second network? So now it's different. It is in parallel. So how we do that? We will be using OR command. This one. OR. Zero. Sorry. And equals 1.2. So as you can see, A, if it's in series, and O if it's in parallel. So let's go on. How about if I put normally close here? What will be the address? What will be the instruction here? It will be AN. So it will be and not. Like this. How about like this? So it will be or not. Okay. So let's go to the third network. Third network will be a series of two inputs. So how we do that? So we'll just use the AND command M.0 A M2.1 and then the output which is M2.2. As you can see, it's very easy. So how about if I put normally close here? Then 2.1 will be normally close as well, AN. Okay, so far so good. Okay, let's go to the next network. So our next network number 4 will be a combination of a parallel and a series input. So how we will do that? So first, we will separate these two first. So how to do that? So it will be the same like this. So you will be using OR and 3.0 and 3.1. So what are the next? So these two series input. So what are the command we are using for series? So it will be AM 3.2 and AM 3.3 and then equals M 3.4. See how it's easy. So this is how you convert ladder into STL. So how about if I put here normally close? So 3.3 will be now and not. And how about this? If I put normal close, then this will become or not. Now, for you to uh, try it online, if we are really correct, we can go online. So I will download this, finish. Okay. Okay. So as you can see, our output is already 1. Why? Because this one is already normally closed. So of course the output will become 1 because here it is closed already. So in order for us to stop the output from triggering, we need to make it 1 and then you can see. So if this one will trigger, output will also become 1. How about the network 1? Of course, it will also, the output will become 1 because we put normally close in our input 1. So let's try putting it normally open. See, as you can see, your output is not triggered. So if we will trigger that one, then the output will trigger. Okay? So how about this combination of series and parallel? So your output is 0 since, as you can see here, you have normally close. So it will, the value here will become 1 and also here will become 1 since you are in parallel. So in order for me to trigger the output, then I need to trigger this input since this is normally open. As you can see, it's getting triggered. Okay, I hope it's very clear. Then let's proceed to uh, not advanced but complex. So how about if I will ask you to convert this into STL. So this is a common logic. This is what we call latching. So how you convert this into STL? So it's very easy. So we'll go to our STL language. We'll insert a network. So first, you need to separate these two. You see, you have nest here, so you need to have, so this is parallel. So what we are going to use? We are going to use OR. So it will be O M 5.0, and the second one is M or M 5.2. Then what next? This M 5.1. So since this is series, you can assign this to and M 5.1. Okay. So after that, the output M 5.2. So okay, let's try. We are correct. So let's see. We are correct. So whenever whenever I trigger this one, so this is normally close. Then we will follow normally close as well. Okay. So our start command will be 5.0. So whenever I trigger 5.0, the output will become triggered. So whenever I release the button, output should still triggered. So as you can see, it is still triggered. Now whenever I press the stop button, which is the input 5.1, the output should stop. As you can see, it stopped. So whenever I release again, it will still remain to stop. Then again, one, still triggered. Then whenever I press the stop button, the latch will disengage. So in this STL, we conclude that we are correct. Now let's convert a complex STL program into a ladder. So I will close this. We will be adding new network, or we can just put it in the network 6. So I have here an STL program. So for a first timer, it will be quite scary to see this, but you might find this easy when I show you. So I will just make this minimize. Okay. Okay. So here A, this is and nesting. So for more details, let's go back to our PDF, and we can see here the and nesting. So here in page 22. So here and with nesting open. So in this PDF, it will show you examples which you can try as well. So a nesting means you have 3 nests. So you have 3 like this. So 1, 2, 3. So every nesting have its closed nest like this. So you need to find also the 3 closed nests. So this is the first close, second close, and the third close. So this one is your first nest. So you need to convert this into ladder. So it will be like this. So M16.1, M16.4. Okay, then after that is your and nut, which is normally closed, M0.7. Okay, so this is your first nest. Since your second nest is also AND, it will be a series. This is your third nest, which is all OR, which means this all input are in parallel. So you have three parallel input. Then this E, this is a German, but we can use I, 23.2. I 3 point I 3.7 M 47.4. Okay, so this is our second nest. Now let's go for our third nest will be this group. So FP, this is a positive edge. So I will just replace this into a normally open. We can use positive edge, but just to remove confusion, I will just put this normally open M1.7. Since you are AN, it should be a series M99.4, M99.5. So this is and not, so we are using normally close. Third, I will just put M20.0 for this. Then A, which means normally open, and maybe I will use 20.1. And then this, what is this? So this is an OR, which means this is the first OR, and then this one is the second OR. So the second OR will be in series. So I will put three series. Okay, and then connected here. So we just put M20.2, M20.3. This is only a representation, this address. The most important is how the ladder looks like. Okay, so be careful, you have OR, that's why I put this group here, since that is OR. And then that is your third nest. So third nest, stop from this. So this is your third nest, second nest, your first nest. Now let's proceed. So our nesting will stop here, followed by an normally closed and M2.4, and then followed by a set command, set output, which is M2.7. M2.7. So alright, we finish one uh, program here. So now we will proceed to the how this output reset. So this is the reset. Then let's convert that into ladder. So this is for the set and this is for the reset. Okay, for the reset, we have here two nests. So we're dealing only with two nesting. So the first one is you have 3. And for our reset, we have 2. So as I said before, eliminate per nesting. So locate the first nest. So this is the one. So since this is the first closed nest, so I will convert this first. So since these are 3 or not, am I correct? Is it 3 or not? No, it's only 2. Why? Because this is already slash out, which means this is not included in your program. So slash out means this is same like programming C++, C hash. So this is slash out. Remove this. This is not included. So only these two. 2 or not, which means 2 parallel input. E, as I told you, this is a German. I will just replace E as I. Since I'm an Asian, I 3.6. Okay. So this is slash out, which means not included. And then followed by EN. So how many AN? 2. So I will just put N 20.5.6. Okay. Now after that, this one, how we put this? So this one will confuse you because it ends up with this or not. So as I said, or not is a parallel. So or not will be placed here. 10.7. So this is our or not. Maybe here. Okay. So that is our first nest. Now let's go to the second nest. Since this is our all or, then we will have 1, 2, 3, 4, 5 parallel inputs. Then or not, 3, 4, 5. Then 2, and 4, 6, 1. Okay, so this is our second nest and followed by our reset output. So N 2.7. Okay, so we are finished. So we have here our set. Okay, and we have our reset. So it's very easy. So all you have to do is to read more about that in our sheet and statement list that can be downloadable online. So other as Semantic Manager have the capability to change this into ladder. I will tell you not all. For example, this one. Siemens cannot change this into ladder as you can see. So not all can changeable into ladder. So thank you for watching and don't forget to browse for another videos on how to learn basic programming in Siemens.